Hello students, in this video we are discussing an example from practical number 1. Prove that every graph of order 6 with chromatic number 3 has at most 12 edges. So let us solve this. We have given a graph and with 6 vertices and chromatic number of that graph is 3. We want to prove that graph has at most, that means maximum, 12 edges. So I am considering G is a graph. Let G is a graph of order 6, means number of vertices 6. G is a graph on 6 vertices and chromatic number of graph G is 3, means chi of G is equal to 3. We want to prove G has at most 12 edges. So to prove G has at most 12 edges. Since we know chi of G is equal to 3. What is given? Chi of G is equal to 3. That means we can properly color graph G using exactly 3 colors. So we can partition the vertex set into 3 parts. So let vertex set of G is equal to V1, V2, I am considering U1, U1, U2, U3, U4, U5 and U6. Chi of G is equal to 3 means we have colored the vertices of graph G using color 3. Suppose those colors are 1, 2 and 3. Suppose 1, 2 and 3 are, I am writing here C1, C2 and C3 are the colors used for coloring of graph G. Coloring of graph G. So if we partition the vertex set of G by using coloring of those graphs, then what type of partition we'll get? Suppose I am writing here, we have this graph 1, I can color this as 2, I can color this as 3 and I can give color 1 to this vertex. So for this graph G, chromatic number is equal to 3. Suppose this vertex is A, B, C and D. So I can partition the vertex set into 3 parts as, suppose first vertex set is capital X1, where I am considering all the vertices with color 1. So the vertices with color 1 are A and C. I am considering the set X2 with the vertices of graph G with colors 2. So 2 color, that there is only one vertex with color 2 and X3 is a set of vertices in G with color 3. So here B is a vertex with color 3. I have given this as an example, but in our graph G we have 6 vertices and all those 6 vertices are colored using color C1, C2 and C3. Therefore we can partition U1, this vertex set of G, into 3 parts. So I am considering those 3 parts as, so we can partition the vertex set V of G into 3 parts according to color of each vertex. So there are 2 possibilities to partition 6 vertices into 3 parts. We have 6 vertices, so we can partition these 6 vertices into 2 plus 2 plus 2, means first set contain 2 vertices, second set contain 2 vertices, and third set contain 2 vertices. And other possibility is we can partition 6 vertices into 3 subsets, as first set contain 1 vertex, second set contain 2 vertex, and third set contain 3 vertices. You may consider first set contain 2 vertices, second set contain 3 vertices, and third set contain 1 vertex, but order doesn't matter here because we are considering partition. That means how many vertices does each subset has. So if partition is like this, 6 is equal to 2 plus 2 plus 2, then what does it mean? Vertex set of G is divided into 3 subsets x1, x2, x3, such that vertex set of G is equal to x1 disjoint union x2 disjoint union x3. What does it mean, disjoint union? Union of all three vertices will be vertex set of G, and intersection of x1 x2 is empty, x1 x3 is empty, and x2 x3 is also empty set. So if we count number of edges in graph G, we can count number of edges in x1 x2, vertices x1 x2, x1 x3, and x2 x3. Suppose x1 has 2 vertices, suppose u1 and u2. x2 has 2 vertices, suppose u3 and u4, and x3 has 2 vertices, say u5 and u6. Then what will happen? Now we are counting the number of edges. This is our x1 and this is our x2. So u1, u2, u3, u4. This is a partition of vertex set of G. So there will be, and what type of partition it is? u1 and u2 receive the same color. u3, u4 receive the same color, and u5, u6 receive the same color. That is, u1, u2 have color 1, u3, u4 have color 2, and u5, u6 has color 3. So we cannot draw an edge between u1, u2, similarly u3 and u4. But I can draw edge between u1, u3 and u1, u4, u2, u4 and u2, u3. So in this case we have 4 edges. In this case we have 4 edges, and we are considering maximum possibility of edges. It can happen that there is an edge between u1, u4, but there is no edge between u1, u3. But we want to calculate maximum number of possible edges in graph G. So I am considering all possible edges. So now we have drawn edges between vertices x1 and x2. Similarly, we can draw edges between vertices x1 and x3. So x1 has 2 vertices, x3 has 2 vertices. So there are again 4 possibilities for number of edges. So these are 4 possibilities. And last, x2, x3. So if we consider this set as x2 and this set as x3, then again we have 4 number of edges, possible edges. So in all, if we consider number of possible edges in this case is equal to, number of possible edges is equal to 4 plus 4 plus 4, that is 12. But we have discussed this partition. 6 is equal to 2 plus 2 plus 2. That means we have divided the vertex set into 3 subsets x1, x2 and x3, where each vertex set has 2 vertices. But there is another one possibility, that is 6 is equal to 1 plus 2 plus 3. So what will happen if the number of vertices divided into 3 parts, such that first vertex set contain one vertex, second vertex set contain 2 vertex, and third vertex set contains 3 vertices. So let us count number of possibilities in second case. So suppose 6 is equal to 1 plus 2 plus 3. That means x1 has only one vertex, say u1, x2 has 2 vertices, say u2 and u3, and x3 has 3 vertices, say u4, u5 and u6. Then how many edges does the graph G have? Suppose this is u1, we are counting number of edges between x1 and x2. This is u2 and u3. So in this case, when counting number of edges between x1 and x2, there are two possibilities. While counting number of edges between x1 and x3, we get three possible edges. Now let us count number of edges between x2 and x3. x2, x3. x2 has two vertices, x3 has three vertices. So possible number of edges are 1, 2, 3, 4, 5 and 6. So in this case, all possibilities are, in first case, in x1 and x2 there are two possibilities, x1 and x3 three possibilities, and x2, x3 has 6 possibilities. So total possibilities are, total number of possible edges is equal to 11. And already we have discussed total number of possible edges when 6 is partitioned into 2 plus 2 plus 2, and the number was 12, and in second case the number of possible edges is 11. So therefore from both possible partitions, we can conclude that G has at most 12 edges. Now what is partition? Partitions means how we have divided the vertex set of G into three parts. First case is 6 is equal to 2 plus 2 plus 2, and in second part we have divided the vertex set of G into three parts as 1 plus 2 plus 3. So we have proved that if G has 6 edges, 6 vertices and chromatic number of G is 3, then G has at most 12 edges. Okay. In our next video we are going to discuss another example. Thank you.